Here is our video on adding and subtracting rational expressions. As you can see, fractions are involved, so the same rules apply as you have always known them to be. Common denominators, you can add or subtract the numerators. Uncommon denominators, you have to change them. So in this first example, I gave a common denominator of 18u. So I go ahead when I show that work and rewrite that in the denominator because I know I can use that for both because it's the same. Now the work in the numerator, always just be careful of the signs. Subtraction's a little bit more difficult because you have to remember you are taking away each of the individual terms written out. So what I do to show that work is I rewrite the first terms, 2u minus v, because those aren't going to change. And then I do subtraction of all u minus 4v. And then from here, when you drop down to actually simplify, we still have 2u minus v, and then we have to subtract u, and then we are actually going to be adding 4v because a negative times a negative is a positive. Still over 18u. And then you just want to go ahead and combine like terms. So I have a u to start. There's 2u here minus another u. That means we are left with 1u. And then we have negative v plus 4v, which means we have 3v, all over 18u. The next example is also a common denominator, except I switched it up to give you an expression. So that's a good thing. We want to keep that. That means we can go ahead and add what's in the numerator. So I do the same thing. I write out the work and have 2x plus 2 in the denominator for both. And then I rewrite the work, and now I'm just adding, which is a little bit easier because I can just say 6x minus 6 plus 6. In addition, you don't have to change the signs. So then I look and combine like terms, and I see I only have two constants that end up canceling each other out. So I have 6x over 2x plus 2. Now, sometimes you're going to have to just double check in the denominator more specifically if you can actually have simplified that, because I see that I have 3 even numbers, so I want to simplify all of them because they are all divisible by 2. So what I do to show that work is I still leave 6x in the numerator, and then I divide 2x plus 2 by 2 because they both have a 2, and 2 is a factor of itself. So when you divide 2x by 2, you're left with an x. When you divide 2 by 2, you're left with 1. It also might be helpful to review my simplifying rational expressions video because I explain how to do this. And then I see 6 and 2 can be simplified. 6 over 2 is just 3 over 1. So I have 3x in the numerator, and at this point I drop the 1 because I don't need a 1 in the denominator. It doesn't change the answer. And you're just left with 3 over x plus 1. This doesn't happen often, and I'm not sure if your homework does have those examples, but if it does, just double check. However, if this was like a 7x, there's nothing that can be simplified, so you'd be fine to leave it as it is. Now the last one. They are unlike denominators, and I did not give you many like this for your homework. So the work is a lot, but I didn't give you too many examples of this. What I do to show the work, because they're unlike denominators, is I actually rewrite both of the fractions, but with a pretty long fraction line because I want to show you how I multiply each of the fractions to have a common denominator. Drop that one down. So what I look for is what is each denominator missing? In the first one, there's an x plus 1, and in the second one, there's an x plus 2. So the first denominator is missing an entire expression of x plus 2. So what am I going to do to both the denominator and the numerator? Multiply them both by an x plus 2, so they each have one of those. And then I look in the second one and do the same thing. This one already has the x plus 2. What is it missing? An x plus 1. So I multiply them both by x plus 1 in the numerator and denominator. The work gets a little crazy. Hold on, that's my dog Penny. Penny, stop. So I'm going to show you how I show that. You never simplify the denominator. You just leave it as the two expressions each in a set of parentheses, and which one you put first doesn't matter. So I'm going to just do x plus 1 and x plus 2, but you can switch them around. Okay. Simplify the numerators. So that means you have to distribute for each of them. So the first one to distribute, I'm going to be saying 3x times x is 3x squared. And then 3x times positive 2 is positive 6x. And then in the second one, once again, be careful because it's subtraction. So I'm going to write down the subtraction sign and throw all the work that I get in parentheses so I know how to distribute the sign. I have 2 times x, which is 2x. And then I have 2 times 1, which is 2. And now we want to go ahead and combine any like terms, but being mindful of this subtraction sign. So just to show you the extra work that you could write out, so everything is simplified, is we have 3x squared plus 6x, but now minus 2x minus 2 all over x plus 1 times x plus 2. Wow, my handwriting got sloppy. And then go ahead and combine like terms. There's no x squared other than 3x squared, so that remains. Then I have 2 x's in the middle. I have positive 6x minus 2x, so that's 4x. And then I'm left with the constant of negative 2 all over x plus 1 times x plus 2. And you're done once I finish writing this all out. There you go.